The reflection in a mirror is called an image. There are two types of images. The one you are looking at is called a virtual image. Virtual images appear upright and behind the mirror. This is an example of a real image. Real images are inverted, can be seen in front of the mirror, and can be projected on a card or screen.
Let's draw a ray diagram to see how this works. There are millions of light rays leaving each part of the light bulb. We're going to trace two of them to find its image. Any light ray coming in parallel reflects through the focus point. Likewise, light rays entering through the focus point will reflect parallel. Real images form where the light rays converge in front of the mirror.
Now let's do some calculations. Starting with the thin lens and mirror equation, we can calculate the distance of the image by measuring the distance of the object and using a known focal length. The inverse of DI equals the inverse of F minus the inverse of DO. By substituting in the numbers, you can see in this case, the distance of the image comes out to be the same as the distance of the object. Next, using the magnification ratio, we know that M equals DI over DO, and it also equals HI over HO. Solving for HI, we get DI/HO over DO. By substituting in the numbers, the height of the image comes out to be the same of that of the object. For a plane mirror, light rays coming in parallel to the optical axis reflect along the same path. For light rays coming in at an angle, the law of reflection says that the angle of incidence must equal the angle of reflection. Where the incident light ray strikes the mirror, we draw a normal line perpendicular to the mirror. We use this line as a reference to measure these angles. Real images occur where light rays converge. Because these light rays don't converge, we locate the virtual image by tracing the extensions back behind the mirror. In a plane mirror, the image is always the same height as the object, and the distance of the image is always going to be equal to the distance of the object.